Hey everyone, this is lesson 522 on completing the square. This lesson is an extension of the previous lesson on perfect square form. So now we're going to actually look at converting quadratic equations that are in standard form into perfect square form, and that's what we call completing the square. So we'll get into that in a minute, but a couple things just to remember. We've done this a while ago, but we have used, in some of my notes, I've used pictures of algebra tiles to help us understand like area model and factoring. We've used some pictures to help us understand and visualize. So we're going to be using that a little bit more on this lesson because I think it helps. So hopefully I could do a decent job of that in this video. It's a little bit better in person, but I'll try to do my best here. And then the second thing is, again, you need to be familiar with perfect square form because really, as we saw in the previous lesson, it allows us to solve equations a little bit more easily than maybe even factoring. So this was another option to solving that doesn't involve factoring. All right, so we're going to have a couple of options. All right, so on this problem, we're looking at a couple of equations, which I'll just tell you now, they're the same equation, they just don't look the same. Right? And so we have a visual picture of both of these, and I'm going to try to do my best to explain what this is showing us. All right, so on the left side, I have a picture diagram that is supposed to represent this equation immediately below it. Right, so the obvious part would be the equals 0, equals 0. So that's still kind of the same. But on the left side, these pictures, these tiles would represent the actual equation. So if you look closely, the first term is an x squared. You'll notice I have an x squared in the picture. There are 4 x's, so you'll notice I have 1, 2, 3, 4 x's, and there's a unit of 1. So there's just one little unit. All right, so this picture and this expression are the same thing. And so what we're looking at, if you notice, if you already kind of glance on the right side, they look very similar, except you should notice that there's actually more little squares on the right side where it actually looks like it's a complete square. Right? So this could be a complete square, but it seems to be missing some boxes. All right, so our goal is to see how can we turn something like this into something like this. And why do we want it to look like this? Why do we want it to look complete? Well, if you look below, and I think I mentioned this before when we looked at perfect square form, is the dimensions of this kind of these algebra tiles, this area model, is x plus 2, which means the area of the whole thing is x plus 2 squared, right? Where I told you that's really the same thing as x plus 2 times x plus 2. And so that is something, this perfect square form is something, if you remember, that's something that we know how to solve by square rooting both sides. So the question is, how can I get this picture to look like this picture? Well, they almost look the same. So, and if you notice, there's actually 0 on this side, and there's 3 little boxes on this side. So how can I get them to look the same? Well, what if I just add 3 little boxes, right? And what if I add 3 little boxes to the other side? So whatever I add to one side, I add to the other. Now all of a sudden the pictures are the same. So if the pictures are the same, then that means these two equations are the same. So that means an equation like this could be written like this in perfect square form. All right, so that's kind of the general idea of what we're trying to do. And so I'm going to kind of show you the algebra steps to help us get there, and I'll go through it a few times. This lesson and the next lesson will kind of cover the same topic. All right, so adding, let's see, actually, the first thing to do to make this a little bit easier, one of the first common steps is to just get rid of this, move this 1 to the other side. And so if I remove this 1, if I do a minus 1, you'll notice I'm left with x squared plus 4x equals to negative 1. All right, so what that means, that pretty much means, is we've eliminated this little square at the top, which is kind of seems like the opposite of what we want to do. But the reason why we do that is just so we could see, and just so I could show you that the reality is if that one's missing, then we need to add 4 little squares, which would be the same 4 little squares that are already here. All right, so you might think, well, why don't we just add 3? That just makes more sense. Technically, we are adding 3, but the reason why we want to kind of make it so we have to end up adding 4 is so I can make this connection with, well, how do I know there's going to be 4 little boxes we need to add here? Well, there's 2 x's here, right? There's 2 here, and there's 2 here. And you'll notice 2 times 2 is 4, right? So I want to be able to use and understand there's a connection between this number and these numbers on the outside, right? This will make more sense when we start to do more of these. All right, so that being said, if the magic number that I want to add to both sides is, oops, let me zoom into this. We really want to add 4 and add 4 to both sides. So if I do that, if I actually add 4 squares, let me color these green, 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 green. All right, so what I notice now is this x squared plus 4x, that represents this complete square, which if we know from this picture on the right side, that's the same thing as x plus 2 squared, which if you think about it, we could actually factor this. We could actually factor this to x plus 2 and x plus 2. So this is either a part where you do whatever you need to do to factor it. So area model, X game, you could do that. Or we could kind of realize there's a pattern here and there's a little shortcut that we could use. And we're going to get to that in a minute. And so I'm not going to review factoring. So either I'm assuming you know how to factor or you're going to hold off till we get to the little shortcut. So this could be rewritten as x plus 2 squared because there's 2 of them. And you should notice on this right side, negative 1 plus 4 is 3. Right, so I'll just keep that down. And so you'll notice at this point we have the same equation. All right, so there is a way. Visually, you saw we could just add little squares to both sides. But this is how we do it algebraically. All right, so this is our goal, to learn how to do this. Okay. And then this is something we would solve. I don't think I'll solve this one because we're going to solve a few more later. But we would solve this, and I'll just do this really quick. So you would have plus or minus 3, and then you would end up with x equals to negative 2 plus or minus square root of 3. All right, so that's something that we've done before when solving perfect square form. And so we'll practice this moving forward. All right, so let's look closely at this again. So completing the square, this name completing the square, really means writing a quadratic equation in perfect square form. Right? So that's why it's important for you to know what perfect square form is. Our goal is to get there. So by completing the square, that's like taking a picture, a diagram, and saying, oh, there's missing pieces, but I want to make it a complete square, even though it's not one already. If it is, then that would make things even easier for us. All right, so I've started this one for us. This one is x squared plus 6x plus 5 equals to 0. We're going to try to solve this one completely. There is a visual picture of this that I've included for us in case you need to see what that looks like. It's not, when we do solve problems like this, I'm not going to ask you to necessarily draw a picture of it. I'm showing you the picture so that you could see where all the algebra steps come in. So I would suggest you include this in your notes, but most likely you wouldn't be including it when you show your work, unless you feel it helps you. If you feel it helps you, then please go ahead and do it. I'm not going to say don't do it. It's an option for you if you need it. All right, so the picture says we have an x squared, we have 6 x's, right? We have 3 and 3, right? You'll notice they're split evenly, and there's 5 single boxes, so 1, 2, 3, 4, 5. So this picture should represent this expression, and they're both equal to 0. All right, so just to let you know, those are the same. The picture and the equation are the same. And so the steps, first step that I'm going to do is, let me zoom into this. I'm going to subtract 5 from both sides, right? That's this first step. And I want to be left with x squared plus 6x, only the x's. And you'll notice now it's a negative 5 on the other side. And so you'll notice I highlighted this in on the right side picture, which, because I want to just kind of visualize that there is a total of, let me see if I could draw these in. All right, there's a total of 9 little boxes that are missing. All right, so in the picture, what we're trying to add is 9 to both sides. All right, so what I'm going to do is I'm going to put a plus 9 and a plus 9 to both sides. All right, so when we simplify this, this is going to be x squared plus 6x plus 9 is equal to negative 5 plus 9 is 4. All right, now our goal is to factor the left side. So this is going to end up being x plus 3 times x plus 3 equals to 4. Which you should see in this picture as well. This is an x plus 3 and an x plus 3, right? You'll notice there's 3 x's and 3 x's. So if you have that picture, it kind of makes it easier. You don't actually have to do a separate area model for it. So I'm going to simplify this. This could be written as x plus 3 squared equals to 4. All right, so at this point, we are in, right, this is in perfect square form. Right, this process is called completing the square. Our goal is to get in perfect square form. All right, now that it's in perfect square form, we could actually solve this. So what I'm going to do is I'm going to take the square root of both sides. So we've done this before. So don't forget this is a plus or minus square root on the right side. so this leaves us with x plus 3 equals to plus or minus the square root of 4. That does reduce, but I'm going to hold off on reducing that for a minute. All right, so the last step is to get x by itself. And so what I'm going to do is I'm going to subtract 3 from both sides, leaving us with x equals to negative 3 plus or minus the square root of 4. All right, so this is, if that was not a 4, if it was a 5, then we couldn't simplify it anymore. But it does simplify some more. So this is actually going to be x equals to negative 3 plus or minus 2, because if you put the square root of 4 in a calculator, or maybe you already know 4 is a perfect square, so that's going to give us a 2. All right, so this leads us into two possible answers. So we're either going to have x equals to negative 3 plus 2, or x equals to negative 3 minus 2. You'll notice the plus and minus 2, which gives us two possible answers, negative 1 and negative 5. All right, so let's highlight those. We have those two possible answers. All right, so that's kind of the general idea of what we need to be able to do. Normally, we may or may not have been able to do this any other way. So factoring is always an option. Sometimes we can't factor everything. Or maybe you're not good at factoring. Here's another option for you that I think sometimes could be a lot easier. All right, so let's go on to the next one. All right, so I've started this one as well. So I like this one because there's a minus 5 on here. And so on the picture, if you didn't notice on the picture, the negative is represented by white squares instead of gray squares. All right, so this is kind of one reason why we end up moving all the numbers, the little squares, to the right side, because they may be positive or they may be negative. So it's just a lot easier if we could take all 5 of these and just move them over to the other side, because none of those fit nicely in this one spot. We really have too many little squares. All right, so if you could already see from the equation, x squared plus 2x, right? X squared plus 2x's, and there's 5 negatives. I'm going to add 5 to both sides so that we could move that 5 to the other side. You'll notice now it becomes a positive 5 on the other side. And now I'm looking at x squared plus 2x, right? Just this part in green. And in order to complete this square, I need one little square, right? So in order to fill this in, one little square, I'm going to add 1, right? I'm just going to add 1 to both sides. So that's our magic number for us. And let me simplify this. This is going to be x squared plus 2x plus 1 equals to 6. All right, and then this is going to factor to x plus 1 times x plus 1 equals to 6. If you didn't know that, I'm just looking at this picture. I see x plus 1 and x plus 1. And so I'm going to simplify this to x plus 1 squared. I'll zoom into this part, equals to 6. And now we're in perfect square form again, right? Perfect square form. And now we can solve this. So I'm going to make this smaller. All right, so let's take the square root of both sides, plus or minus square root, and we're left with x plus 1 is equal to plus or minus the square root of 6. And we're going to subtract 1 from both sides so we can get x by itself, right? We're still trying to get this x by itself. And we're left with x equals to -1 plus or minus the square root of 6. All right, 6 is not a perfect square, so it's not going to reduce to a nice small number. So if it was a 9, then we could take the square root of it. If it was 25, if it was 16, 49, 100, those are nice numbers. But if not, then we're just going to leave it in exact form. We don't want decimals at this point. Unless the question specifically asks you for a decimal or approximated answer, then you could just type it into a calculator. All right, so this splits up into two answers. So let's just split these up. So this is going to be x equals to -1 plus the square root of 6, and x equals to -1 minus the square root of 6. All right, so those are our two answers for this equation. All right. All right, so hopefully you're getting kind of the hang of this. That's kind of the basics of it. The next set of questions, I just think I have, just these three. All right, so I'm going to go over these three. I'm going to reduce the work even a little bit more, skipping some steps. You'll notice there's no pictures here. I'm going to do these without any algebra tiles. I would probably recommend you pause the video now and you try to do these and see if you get the same answer as I do. If you're still a little bit confused, then don't pause it and then just follow along and see if you could keep up. Again, the next lesson, I'll be going over this some more. Completing the square is covered in the next lesson as well. So hopefully between the two lessons, it'll make sense to you. All right, so here's three equations. I'm going to focus on one at a time. Hopefully I'm not going through this too fast. If I am, definitely pause it or feel free to ask me questions about any of these. All right, so first one, I'm gonna add 5 to both sides. All right, first step is always the same. X squared plus 4x is equal to 5. Now, this is the part that's going to be a little bit tricky for some, and that is what is the magic number I need to add? Now, with a picture, it was a lot easier. So I'm gonna go over that more on the next lesson, but I'm just gonna tell it to you now. This magic number comes from, this 4. So I'm going to take 4 and cut it in half, and that's a 2. And then so I'm going to add 2 to both sides. So 4 divided by 2, and I'm just going to put it there. All right, and so that means I'm left with, we could factor this, and this is going to be x plus 2 squared equals to 7, and it's already in perfect square form. So, and you'll notice this 2 is also this same 2 inside as well. All right, so I'm going to square root both sides, and I'm going to be left with x plus 2 equals to plus or minus the square root of 7. And then I'm left with x equals to -2 plus or minus the square root of 7. All right, and that's it. All right, so you'll notice it looks a lot shorter here than the previous problems. I'm still showing a lot of work, but there are some in between steps, instructional steps that I kind of skipped. All right, so that leaves us with two possible answers, -2 plus the square root of 7 and x equals to -2 minus the square root of 7. All right, so that's one pair of answers. And then I'll go on to the next one as well. let me add 1 to both sides. We're left with x squared equals to, or x squared minus 6x equals to 1. And then I'm looking to see what number do I add to both sides. And I'm going to look at this 6. So I have a negative 6. Half of negative 6 is negative 3. I'm sorry, I made a mistake on here. I can't believe I did that. My bad. This is all wrong. See, I caught my own errors. How embarrassing. All right, so correction here. This is 4 divided by 2. I forgot the part where I have to square it. Sorry. So 4 divided by 2 squared is a positive 4 to both sides. All right. Silly me. All right, so that means we have x plus 2 squared. All right, that's still the same. X plus 2 squared is still the same. But now it's going to be a 9. All right, so now that's going to be a nice number. So sorry about that. So x plus 2 equals to plus or minus the square root of 9. And then I'm going to subtract 2 from both sides. So that part was still the same. So the answer was almost the same. So I just made that error on this number. All right, so let me fix that. This is going to be x equals to negative 2 plus or minus 3, right? And that is a 9. Square root of 9 is 3. So we have 2 possible answers, x equals to negative 2 plus 3 and x equals to negative 2 minus 3, which means we have x equals to 1 and x equals to negative 5. All right. Sorry if I confused you on that last one. All right, so on part B, now we go back to part B. When I want to figure out our magic number, I'm going to look at the 6. So I have negative 6 divided by 2, and I'm going to square it. So negative 6 divided by 2 is negative 3. Negative 3 squared is going to be a positive 9. So I'm going to add 9 to both sides. So plus 9, oops, wrong color, plus 9 and plus 9, which means we're going to have x minus 3 squared equals to 10. And so why is it a minus 3? Well, that comes from this minus 6. Like I said before, negative 6 divided by 2 is negative 3. All right, so again, if we had the picture, if we had actual algebra tiles, I would have 1, 2, 3, 4, 5, 6, and then inside I would have a total of 9 missing squares. So it's this 9, here's your 9. That's where the 9 came from. But here it's a minus 3 and a minus 3. So that's where the x minus 3 comes from. All right, so I'm going to solve this, and this is going to be x minus 3 equals to plus or minus the square root of 10. I'm going to add 3 to both sides, and we're going to have 2 possible answers. So we're either going to have x equals to 3 plus the square root of 10, and x equals to 3 minus the square root of 10. All right, so that's the set of answers for that one. All right, and then the last one, you'll notice all those were set equal to 0. Parts A and B, you'll notice those equations are set equal to 0. On C, you'll notice it's set equal to 1, which doesn't change anything about what we're doing. All right, so the first steps are still going to be the same. I'm still going to add 3 to both sides. Here, I'll zoom into these two. And we're going to simplify that. X squared minus 2x equals to 4. And then I'm looking for the magic numbers to add to both sides. So what I'm going to do is I'm going to look at -2 divided by 2, and then I need to make it a perfect square. So that's going to give us a 1. So this is going to be a +1 and a +1. All right, because half of 2 is 1, and 1 times 1 is 1. All right, so that means we could factor this. This is going to be x minus 1 squared equals to 5. And we could solve this. We're going to take the square root of both sides. So this is going to be x minus 1 equals to plus or minus the square root of 5. And then I'm going to add 1 to both sides. So this is going to be 1 plus or minus the square root of 5. All right, so which means we're going to have two possible answers, 1 plus the square root of 5 and x equals to 1 minus the square root of 5. All right. So I know I skipped some steps there, like I didn't really show what number am I adding to both sides. I did say it, but if you need more examples where I'm showing you more details, kind of like on the previous problems, then let me know so I could get that to you. Else, just look back at the previous problems where I was showing a bit more work. All right, so you'll notice if you keep looking back at the previous steps, you should see what I kind of eliminated and what I didn't. So problem 74 is a good one to kind of see all the work. On this one, 75 is more of where we're headed. Hopefully you could get here so there's less work, but not too much less. So you shouldn't really have less than this when you do it. All right. Next lesson, I'll formally give you like official steps on how to do it to explain what I was really doing on problem 75. So hopefully that helps you as well. So if you maybe wait till you watch the next lesson before you ask me more detailed questions if you need more help. All right. That's it for now. See you next time.